All right, this is question 60 from the AP Classroom review, and I will admit this one threw me for a loop at first. It's really in the wording of this problem. At time t is greater than or equal to 0, a cube has a volume v of t and an edge length x of t. If the volume of the cube decreases at a rate proportional to its surface area, which of the following differential equations could describe the rate at which the volume of the cube decreases? Okay. This is, while it sounds like a related rate question, and that's what it would end up being, it's not really what it's asking. So let's talk about a few key words. First, we have a rate. The volume is decreasing at a rate. We'll get back to the word proportional here in just a second because that plays a part too. So really what we're looking for is a dv dt. That's pretty obvious given what we see in the answer choices. All of them are dv dt. So that really doesn't help me much. And really not even knowing the volume formula for a cube is fine because that's not really what it's asking. What it is asking, however, is that it's proportional to something. So you're going to have to dig deep. But to remember that the idea of proportionality says that our two values need to be related by a factor of k. So this is an example of y being proportional to x. They're proportional, they're related by that constant, what we call a constant of proportionality. That's that k value. Now, let's put it to the words of which this talks about, and it talks about it being proportional to its surface area. So if you can picture a cube, and we know each side length is x. Drawing is not my strong suit. So we have this cube here, and each side length is x. When we look at the surface area, if I consider the idea of each of these little squares that we have in there have an area of x squared, and then there's 6 sides to the cube, the surface area for a cube is 6x squared. Okay, now it says, again, the volume of a cube decreases at a rate proportional to, so we're talking about dv dt. So dv dt is proportional to, but it's decreasing at a rate proportional to. So we would add a negative k constant times this 6x squared. Okay, now this is what the problem is saying based off of just those words. Now, it then asks which of the following differential equations could describe the rate at which the volume of the cube decreases. And if we look at this, I know if I simplify this, you're going to see that this just gives me negative 6k x squared. A couple things I want you to pay attention to. One, in all of my answer choices, I only have one place where I only have x squared. This doesn't have a t attached to it. It's not multiplied by the time. It's dealing with the sides. It's not dealing with the volume. It's not dealing with x cubed. So it really can only be x squared. But so let's talk about that negative 1.2. We don't know in this problem what that constant of proportionality is. It just says which one could describe it. So really what we're looking at when we talk about that proportionality is we're looking at this expression needs to be equivalent to or is equivalent to this. Why? We don't know. And it's not really that important. We just know that negative 6k is equivalent to the negative 1.2. And then, of course, we have the x squared here and the x squared here. And so my answer choice on this one is A. And it's based on that word could, and it's also based on the fact that the volumes of the cube decreases at a rate proportional. And we have to go back to Algebra 1 to remember the idea of proportionality. So there's problem number 60.